Today we're going to finish up what we started with transformations. I'm going to give you a brief recap of translations and reflections, and then I'm going to work through the activity for rotations using the TI Inspire software. And you can follow along depending on where you left off in class. So as a summary for translations, a translation, if you shift it up, down, left, or right, it's simply a slide or a shift in the horizontal and or vertical direction. You write the original point as x comma y, and the translation is described as x plus a and y plus b. Oops. Where a is going to be, that's not working, is it? A is going to be your shift left or right, and b is your shift up or down. Obviously, if it's positive, it's moving to the right, negative, moving to the left. If it's up, we're positive, down, we're negative. The same thing you all saw with graphing coordinates way back when you first started graphing in the coordinate plane. And that's what you should have seen with translations. With reflections, you should have seen that if you reflected something over the x-axis, then your y-coordinate changed signs. You multiply the y-coordinate by -1. So if it was positive, it became negative. Or if it was negative, it would become positive. So when you reflect over the x-axis, it's the y-coordinate that changes. The opposite is true for a reflection over the y-axis. The x-coordinate would be multiplied by -1. If it was positive, it would become negative. If it was negative, it would become positive. And you should have also discovered that if you reflected over both the x and the y-axis, it would end up being that both coordinates would be multiplied by -1, so both coordinates would end up changing signs. So that's a brief summary of what we covered with translations and then reflections. Now I'm going to go through the activity for rotations. So you would see something like this as the first page for rotations, and I'm going to read off the directions. You should be following along right now. This is page 1 of rotations. It says, a rotation is the turning of an object by an angle about a fixed point. How does the image of a rotated object compare to its pre-image? In this activity, you'll use clockwise and counterclockwise rotations as you investigate the properties of the pre-image and the image of a triangle, so the original figure and the rotated one. So it says move to page 1.2. The directions for number 1 say determine if a rotation of a figure changes the size or the shape of a figure, and you all should have probably at least gotten through this. Part A says two figures are congruent if they have the same size and shape. Move point P on the clockwise one, which is this blue one at the top, and observe the rotated image. Does the rotated image appear to be congruent? Well, if we rotate this, yes, it appears to be congruent. It doesn't look like our size is changing, our shape is changing. We're just simply rotating its position. So that's going to be, yes, they are congruent. And you can describe that as you just saw. The size and shape don't change. Same thing for part B with counterclockwise. If we were to change this, then again, size and shape don't change, so that congruence is maintained. Number 2 says an isometry is a transformation that produces an image that's congruent to the pre-image. Is a transformation by a rotation isometry? Well, yes, it is by definition, because a rotation preserves congruence. The pre-image and the image are both congruent to each other. So number 2 is that yes, it will be an isometry. And for number 3, move point Q on the counterclockwise circle until the degree of rotation is 60. So I'm going to move this down here until this becomes a 60-degree rotation, which will be right there, counterclockwise. For part A, if you move point P up here on the clockwise circle, when will the two rotated image be in the same position? Well, if I were to rotate this clockwise so that my blue triangle is on top of this red triangle, so that both rotations are in the same position, that's going to be at 300 degrees. So for part A, it will be at 300 degrees. What do you notice about these two numbers, the 300 and the 60? Well, they add to give us 360. And you can see that over here, that creates a full circle. So a clockwise rotation and a counterclockwise rotation will end up giving you the same position if those two numbers add to give you 360 degrees, a complete circle, 360, which ends you up back in the same position. Kind of like if you were to stand in one position and do a 360-degree turn, you'll end up in the same position that you're in. That's why I laugh when people say, I turned my life around, I made a 360. That doesn't really make sense because 360 end up in the same spot. So they should say 180, which is, halfway around. Anyway, a little side note for you. So turning the page to page 2, it says move point P on the clockwise circle, which is up here in the blue one, until the degree of rotation is 150 degrees. So I'm going to move it towards at 150. Part A, if you move point Q, when will the two rotated images be in the same position? Well, it should be when they add to 360. So I'm going to move this, and I end up at 210. And if I add 210 degrees and 150 degrees, I end up with 360. And again, I form a complete circle. One of them rotating this direction, one of them rotating the other direction. Moving on to number 5. Again, if the angle of the clockwise is 135, so I'm going to move this to 135, which, I can't do it, so I'm going to have to do this hypothetically. Then what counterclockwise rotation will give you the same image? Why? Well, the question is, what number plus 135 can give me 360? So if I take 360 and subtract 135.
What's the other day? May 24th.
And if we subtract those two, we'll end up with a measure of 225 degrees. So the clockwise rotation of 135 and the counterclockwise rotation of 225 will end us in the same position. That's for part A. For part B, if the angle of the clockwise rotation of a pre-image is n, then what's the counterclockwise rotation that will give you the same image? Well, just like we did for part A, we'll subtract the number from 360. So 360 minus n will be the counterclockwise rotation. So that expression, 360 minus n, will be the correct expression for part B in general. How you find the counterclockwise rotation? Take the clockwise and subtract it from 360. That concludes page 1.2. Moving on to page 2.1 for number 6. It says use the slider to examine the difference between a positive and negative angle of rotation. So we're going to use this slider right up here. If I can make that move, that'd be great. There we go. Part A, start with the slider on an angle of rotation at 0, which is where it's at. Move the slider 0 towards 360 and watch the image as it rotates. Does the triangle rotate in a clockwise or a counterclockwise direction? So if I'm moving in a positive degree rotation, looks like it's moving counterclockwise. So that's a counterclockwise rotation if we're rotating it in a positive direction. For part B, the same thing. If we're moving in a negative direction, we're rotating clockwise. And 360 end up back in the same position where you started. Now this is especially important because when you get to Algebra 2 trigonometry, this is very helpful when you're dealing with trig functions and graphing them and exploring the properties of trigonometric ratios. So whenever you're moving in a negative direction when you're rotating, you're moving clockwise. Positive direction is counterclockwise. For part C, what can you conclude about positive and negative angles of rotation and their relationship to clockwise and counterclockwise? I just kind of sum that up for you. If you're moving negative, it's clockwise. Positive is counterclockwise. Moving on to number 7, which is on page 3, complete the first row of the table below with coordinates of vertex A, -6, 1. Well, for that, I'm going to go ahead and get out a chart for us. So in your chart, we're going to start in row A, dealing with the point -6, 1. And we're starting at -360 degrees, which is where we're at here. Well, the rotation from the first one, -6, 1, our new one is the same thing, -6, 1. Because again, 360, you're in the same position, so nothing's really going to change. So for our first one, that's going to be -6, 1. Our next rotation is -270 degrees. So I'm going to move this to where I'm at -270. And you see my figure has rotated to the new position. And my new coordinates are -1 and -6. Notice we have the same values, but switched in order, and the negatives and positives are being adjusted. So our new one is -1, -6. When 880 degrees is our next one, and here we are at 6, -1. And it almost looks like a reflection over both axes here, possibly. So 6 comma negative 1. Continuing on for negative 90, I'll do this one, then I'll fill in the rest for a summary here. Negative 90, we are at 1 comma 6. Both are positive. And if you would fill out the rest of this chart, we end up here with negative 1, negative 6, using the same method we used before. 6, negative 1. That one was given to us, and then negative 6, positive 1. Now we are told to use a new point. Well, for the sake of the length of this video, I'm not going to do B with the new point. We're just going to use our first point and notice the relationship here. So, using our original coordinates, x and y, they stayed the same with the negative 360. They stayed the same at 0. They stayed the same at positive 360, which they should, because all those points are in the same location. Remember, 360s always end you back where you started, whether it's clockwise being negative or counterclockwise being positive. So, when we went to negative 270, though, our coordinates changed positions. We switched the 6 and the 1, so we switched x and y, and then our 1 became negative instead of being positive. So it became the opposite, so we wrote this as negative y and positive x. So if we were to rotate any sort of figure negative 270 degrees, which is moving it clockwise, we'll end up with the coordinates are switched and the y's become negative. Or if it was negative, it would become positive. At negative 180, we didn't switch from our original, but both of our signs switched in the 6 and the 1. Our negative 6 became positive, our positive 1 became negative, so we'll say this is negative x, negative y, which is exactly what a reflection over the x and y axis looks like. So I was correct in my assumption there. For negative 90, they both switched, and they're both positive in this case. So that's going to be y and negative x, because my negative 6 became a positive 1. And going ahead, and you can fill in the rest of this table yourself with the information. I'm going to go ahead and do it very quickly. This should be negative y, negative x. This should be negative x, negative y, and y, negative x. And you'll notice that some of these match up together. We have the 360s and the 0 match up. We have negative 180 is the same as positive 180, because if you turn negative 180 degrees or positive 180, you're still in the same position. So you'll see that some of these match up together. So that's the summation of the chart for number 7. We're going to use this to look at some conclusions. For number 8, if the clockwise or counterclockwise order of the vertices of the image and pre-image is the same, the figures are said to have the same orientation. Do A, B, and C and A prime, B prime, C prime have the same orientation? Why or why not? Well, let's look. If we rotate these, do they still have the same orientation? If I count clockwise, A, C, B, over here should be the same. A, C, B. Let's see if that holds true in a different position. Let's try at 180. A, C, B, A, C, B. So they do hold in this case, so maybe it's slightly different from a reflection, because in reflection it wouldn't hold. It looks like a reflection, but some of the properties are a bit different. The orientation does stay the same, because if we count the vertices clockwise, they're in the same position, ACB, ACB. So orientation is the same. For B, does your answer to question A depend on the direction or the angle? Well, we know it doesn't depend on either because we just checked. We rotated it positive 180, and if we rotated it negative 120, the order of the letters still holds the same. So positive and negative doesn't make a difference, and the actual angle measure, whether it's 120 or 180 or something else, doesn't affect it. So for part B, no, it does not depend on the angle or the direction. And finally, for page 3.1, number 9 and number 10, use the point on the circle to change the angle of rotation. Use the slider to change from counterclockwise rotation to clockwise, counterclockwise and clockwise. Part A, record your observations as you change the angle and direction of rotation. What changes? We're looking at these things down here. So if I change my degree, perimeter doesn't change, area doesn't change. I change from counterclockwise to clockwise. Nothing's going to change. Everything stays the same. So for part B, move any of the vertices of the pre-image triangle. So let's move this one. There we go. Does the new location of these points affect your observations in part A? No, both of them change the same. They both still match in perimeter and area. So they both still match, and my rotation, again, doesn't affect perimeter or area. So the new locations does not affect our observations in part A. So finally, for number 10, consider the properties of side length, angle measure, perimeter, area, and orientation. Which of these properties are preserved in a transformation using rotation? All of them. We see here area and perimeter don't change. We saw in the last slide that orientation doesn't change. Side length isn't going to change. Both these triangles are still congruent because the perimeter is the same. And we can see that none of the side lengths are changing just because we changed the position. So in this case, all of them are going to be preserved. So that concludes rotations. Hopefully this will help with your homework assignment, especially that chart, which was in number 7, which is also very helpful when you're introducing trig functions in Algebra 2 trig.